So we have a very simple question, that is 9.6. A prism is made of a glass of unknown refractive index, and refractive index of the glass that is made the prism is unknown, and the parallel beam of the light is incident on the prism face. The angle of minimum deviation is measured to be 40 degrees Celsius. The angle of minimum deviation, that is del mean, and it changes as the medium changes, right? So what is the refractive index of the material of the prism, right? So this is not given and all the things are given, so you can easily find that. And second thing is the refractive angle of the prism is 60 degree, that is A is given 60 degree refractive angle. If the prism is placed in water, they have changed the medium from air to water, that you can see here. They have changed the medium from air to water. So then what is the refractive index of the water is given. Then predict the new minimum angle of deviation. D mean new, you have to find the same parallel beam, right? So before starting, let's see the theory, and it will going to be very simple when you know the theory of this. So the theory here, we have the mind map of ray optics, and आप यहाँ पर देख सकते हो कि आपके पास सारे जितने भी important concept है सारे के आप यहाँ पे माइंड मैप और यहाँ पे डिनोटेड है, आप इसे रिवाइज कर सकते हो. और particularly this question has arisen from prism. So in prism, the formula we know, that is mu relative is equal to sin a plus d by 2 by sin a by 2. एंड यहाँ पे थ्योरी में क्या है आपका कि ये जो म्यू रिलेटिव है, इसका मतलब क्या है कि प्रिज्म आपका किसी मीडियम में रखा हुआ होगा, है ना. तो अगर यहाँ पे आपका म्यू रिलेटिव, अगर मान लेते हैं कि यहाँ पे म्यू रिलेटिव आपका है, म्यू रिलेटिव आपका यहाँ पे है, और ये प्रिज्म का मीडियम जो है वो एयर है, तो आपका क्या होगा, ये ग्लास का बना हुआ है, तो म्यू ग्लास बाय म्यू एयर इज योर म्यू रिलेटिव. अगर मान लेते हैं कि ये जो मीडियम जिसमें आपका प्रिज्म रखा हुआ है वो वाटर है, तो म्यू रिलेटिव आपका क्या होगा, म्यू ग्लास बाय म्यू वाटर, राइट. सो दिस इज रिलेटिव मीन्स. And similarly, as you going to change the medium, the minimum angle of deviation is going to change, other thing is going to be constant, right? So this is the theory, and now let's solve this question. So let's start with the given that you always write. Given that, first of all, that you have to write in exam. Then minimum angle of deviation is given for the first case in the air prism system. Then for minimum angle of prism is A is equal to 60 degree refractive angle, and that is always going to constant, and the refractive index of water is given 1.33, right? So again, what is happening here is first of all, in first case, the prism is situated in air, put in air, right? And then in the second case, it is the air is removed and water is the prism is placed in water, right? So water here in the second case, you can see. Now what happened will is the d, that is minimum angle of deviation, here is going to be d, and in the second case the minimum angle of deviation is going to change. The minimum angle of deviation is going to change, and you have to calculate that, right? So now let's see how I have calculated this and how you can write this in your exam. So first of all, you have to write that refractive angle of the prism of the material that you have to find in the first case. That is the first question that is given, refractive index of the material of the prism that you have to find, right? So let's start. Formula for the prism that you have is mu g is equal to sin a plus d by 2 divided by sin a by 2, simple. Then mu g, and mu g is not mu g because mu air is equal to 1, that's why I have written mu g. It is mu g by mu a, and that is this. And after calculating this, you will going to get mu g by mu a, mu g by mu a, and it is mu g because the mu a is 1 that I have told you earlier. So that is going to be your 1.532 in numerical value of the refractive index, right? So that is unitless. And after that, hence the refractive index of the glass is 1.532 that we have calculated. Now you can calculate the deviation that you got while situating that prism in water, right? So simply what you have to do here is you have to calculate the angle of minimum deviation when placed in water. So you have to again use the same formula, but here the deviation angle is going to change, minimum angle of deviation. Or you have to do is 1.532, we have to put the value of mu g, and then you have to put the value of mu water, and you have to put the value of a, and d you have to calculate, right? So simply by putting all the value, here we have put it all the value, and put all the value, and then after that, by calculating it, you have calculated that sine inverse, and there is some uh, complication in calculation in the board exam. With this question came to you, the theory or value is given to you for the sine that is used here, or the theta that is used here, right? So don't bother for that, and just focus on the approach of the question. Then you have to solve for this, and you have to find the new minimum angle of deviation in the prism water system. And now the minimum angle of deviation is 10 degree Celsius, 10 degree, sorry, and 10 degree that you have obtained, right? So that is your answer. Okay, so I hope it is very clear to you, and you have to see the, you can also see the question solution here, as well as you can also revise the theories of the ray optics. That is very essential, and very, this chapter is very long, so you have to keep revising it again and again, otherwise you will not able to retain that all the concept that is in there, right? So try to see that, and try to see the solution that is provided here. Okay.